Ladies and gentlemen, please welcome NXP Executive Vice President and General Manager, Secure Connected Edge, Rafael Sotomayor.
The music. Good morning. I'm extremely excited and honored being here, and thank you for being here with me. My name is Rafael. I come from NXP. NXP's mission statement is bringing together great minds to create breakthrough technologies to make the connected world better, safer, and more secure. And this is very fitting when you think about this year's COMPUTEX theme, which together we create. There's a lot of talk, and for the right reasons, there's a lot of talk lately on technologies like cloud computing, generative AI, big data, machine learning. See, at NXP, we're focused on bringing those technologies and much more to the edge. Real life happens at the edge. See, edge devices are there helping us live our life, making decisions, interacting with the environment. Real life has motion. Real life has context. Real life is real time. See, I come from a company, and come from the perspective of a company that focuses on some of the most important areas in connected edge. Smart factories, smart cities, smart home, automotive. See, in the mindset that we have at NXP, when we look at our products and our IP, is that we're maniacally focused on the use case. The use case, and then the future evolution of the use case. So that way, when you invest on us, that investment is generational. That investment is generational. See, edge products and edge devices are making decisions. So they need fit-for-purpose compute solution, fit-for-purpose machine learning capabilities. Edge devices are connected, so they need not only connectivity, but they also need security because they're connected. Edge devices control and operate motion, so they need functional safety. And edge devices are interfacing with life. And life is analog. So they need advanced sensing and smart analog capabilities. The confluence of all these technologies that come together into the device to make a particular use case happen is complex. Complexity of edge devices increasing at a faster rate than ever. In managing complexity, that is my topic in today's presentation. Managing complexity. I contend that in order to manage complexity, you have to focus on the use case and the evolution of that use case. You see, that is easier said than done. It's hard to predict what the evolution of the use case is going to look like. It's hard to predict it. Sometimes, when we develop our products, it takes 3 to 4 years to develop the IP. It takes another year and a half for the OEM to put it into production. We're looking at 5 years. It's hard to intersect the future 5 years from now. Future happens exponentially. We don't think that way. So the best way to predict the evolution of that use case is to focus on the ecosystem. Focus on the ecosystem. Standards, regulations, partners, customers, they're all going to cooperate and converge to help shape requirements, use cases. They all cooperate and help and shape the ecosystem. So before I get into more details on that thesis of managing complexity with an ecosystem, I want to show you what we do at NXP also to manage our own complexity and the partners that we select. And I'll make specific on our partners here in Taiwan. Taiwan is a great place to talk about ecosystems. It's a place where manufacturing, technologies, products, they all come together to invent the future. The reason the names on this list are consequential is because they focus on the use case, they focus on the ecosystem, they focus on inventing the future. We have great partners here. Everything from ODMs to EBS boards, to industrial, to 5G, to connectivity. And you can't come to Taiwan and talk about ecosystems without talking about semiconductors, foundry, packaging, test. They all play a leading role in our industry like no other ecosystem in the world. They have a unique symbiotic relationship that really drives and shapes the future of semis. In that spirit, NXP partnered with TSMC, a strong ecosystem partner, to develop technologies that is going to set the direction of industries. Last year, we announced our first 5-nanometer development with TSMC to develop automotive processors. They're meant to influence the architecture, the future architecture of the software vehicle. We're also developing different types of technology, adjacent technologies. We just announced the first auto-grade 60-nanometer non-volatile MRAM. Another great example, and another Taiwanese partner of ours, is Foxconn. Rich talent for shaping ecosystems. There are many industries, consumer electronics, networking, computers. They have a unique ability to mix their hardware and software expertise with their manufacturing. Foxconn redefines categories. Our partnership with Foxconn and automotive is aimed to push and drive innovation in electrification, push innovation in UWB's car access. It pushes the innovation in cockpit and telematics. This decision by Foxconn, it's not a one-off, it's not a point solution. It's a very strategic decision made, and it's a broad initiative to drive the future vehicle architecture, drive the ecosystem, shape the ecosystem. So when we talk about complexity, we're talking about complexity emanates from many sources, and it helps to put a framework around it so we can think about how to manage it. So these are three categories in the way I look at complexity. The require, these are your table stakes, what you need to develop a product. The differentiating, this is the attributes that you select to create your own value proposition. And then the unforeseen. These are scary. These are scary because we need to be resilient to things that we don't know how to plan for. So the require, in the past, these were the main, I would say, criteria that you used to use to select components. These are your DMIPs, power consumption, software enablement, BOM count. These are important, don't get me wrong. They're expected, and they're not static, they evolve, so there's a source of complexity. But solving for the require and only for the require is not enough. And it leads to point solutions. Now, the differentiating, this is how you choose to be different. And this is when you start thinking about your partners, your vendors, no more as point solutions. Start thinking strategically. Can they give me the differentiation I need? Can they keep up with my differentiation? And then the scary ones. These are the black swans. This is a metaphor used here in the industry to describe events that they're difficult to predict, but they can have a meaningful impact in our business. They're supposed to be rare, but lately they seem to happen quite often. Pandemics, dislocation in supply, regulations, IP restrictions. This level of complexity needs more attention. If you want to be resilient, this has to have a priority. Picking a partner that helps you navigate, who gives you the best chance to navigate through these unforeseen events, is critical. You have to think about your partner. Do they have resilience in supply? What is the geographical footprint? What is their IP coverage? This needs more attention. This has to have the same level, if not more, level of scrutiny that you put in deciding your DMIPS, your power, your board space. This needs that level of attention. So, if the key to success is to solve complexity generationally, over and over, then you need to make sure you position yourselves importantly in the ecosystem, that you partner with ecosystem shapers, and you partner with companies that are able to help you navigate the unforeseen. Selecting a chip is not enough. You know, the days that looking at a data sheet and selecting a product, those days are gone. So let's bring this thesis of solving complexity through ecosystems, let's bring it alive. Let's start with a simple use case just to get us warm. Let's get on warm up here. Simple use case and a local use case. Just a really nice use case. Taiwan transit ecosystem. So at first glance, ticketing, simple use case. How difficult can it be? But then it evolved. It got richer, got more ambitious. It went from paper tickets to magnetic stripe tickets to contactless tickets to now creating digital keys, digital credentials, downloading your tickets into your phone, into your wearable. See, we started this journey in Taiwan in 2000. NXP started this journey in 2000 in Taiwan. We engaged with Taiwan Smart Corporation to start the first evolution of that user experience from magnetic to contactless. Then, what happened is that we realized this is a complex ecosystem. There are multiple transit operators. It's not just one. There are system integrators that manage the back-end office of ticketing. Then there's hardware. There's infrastructure. There's readers. They need to be upgraded. They need to be probably replaced. We realized this was a complex challenge, but we follow the use case. We continue. EasyCard launched in 2009 with e-tickets and micropayments using NXP MyFare. Then iPass Corporation came in 2013 and issued electronic tickets as well. And we started developing a product that they wanted to be able to download tickets over the air. We started developing a cloud infrastructure to build credentials over the air. And then finally in 2018, iPad's release with NXP and Fitbit, what was the first implementation in Asia of the ability to deliver tickets and purchase tickets using your wearable. Now, why was this example such a good example? Simple, but good example, because the use case drove the development of the technology. They push an incredible insight into us. We use them to give us insight into the use case, and they lean on us for technology. What we contributed to this deployment was great knowledge in contactless, end-to-end solutions from cars to readers, a supply chain that they can able to deliver all the components to make this system happen, and more important, the willingness to invest in what was then the future use case. Smart factories is another segment that is going through a revolution right now. It's being reinvented. The World Bank estimates that about 18% of the world GDP comes from manufacturing. 18, that's $17 trillion. So no wonder governments and industries are trying to improve efficiency, reduce downtime, protect the factories, create resilience. But what is a smart factory other than being smart? It's an interconnected network of devices and machines that work together to create things efficiently. So, but the ecosystem manufacturing is complex. There's all these webs of interconnected relationship with stakeholders. You have governments and regulators who are establishing the laws of safety, laws of security, or energy consumption. Then you have the demand creators, the consumers. The population of the world is going to increase, estimated to increase, but 2 billion people in the next 30 years. 2 billion people. We need products to get to the market faster. We need a strong infrastructure, more resilience, higher productivity. And then you have connecting all these corners, the makers, companies like us, semiconductors, software, OEMs. OEMs like Schneider. Schneider is a leader in industrial, and they have a very strong vision on what the smart factory is, and it will be. So I'm going to let Ali, Dr. Ali and Schneider, give us his vision on the smart factories.
At Schneider Electric, we are supporting our customers to build smart factories. Smart factory is a factory which is flexible, efficient, resilient, and sustainable. With our EcoStructure, the IoT-ready and open platform, consisting of connected products, edge control, and software, we are delivering the solutions for that. We can showcase this in our own factories, where we can reduce energy by more than 10% and improve, for example, the maintenance costs by more than 30%. We have been recognized several times by the World Economic Forum for that, and we are incorporating the latest technologies in our products like edge, cloud, connectivity, and AI to deliver on this promise.
Schneider is also another example of a great partner that we have in industrial. You know, they drive, they think about the ecosystem, try to shape it. Clearly, the manufacturing floor is being reinvented because the incentives are, from an economic perspective, are very strong. A trillion with a T, dollars of cost of unplanned downtime every year. Our manufacturing floors need to be more efficient. They use an enormous amount of the world's energy consumption per year. And obviously, waste management is a big deal. So Dr. Ali talked about flexibility on a factory. So what does he mean by flexibility? The factory floors, flexibility means that a factory floor can be reprogrammed, reconfigured to make different products with minimal downtime. So reconfigurability of a factory floor is a key innovation driver for efficiency. Key. So when you think about a factory floor, that's the complexity. We're trying to solve certain pieces of complexity here. If you think about a factory floor, there are tons of sensors, actuators, motors, they're all generating data. And that data sometimes needs to be analyzed. And sometimes it's even better to analyze that data at the edge. Sometimes it's even required. And that is going to happen. It's very clear that we need to offer our customers a broad spectrum of compute solutions so they can leverage their software investment. From low-cost MCUs to high-performance microcontrollers. Many times these devices need machine learning. They need AI. Think of predictive maintenance. And today, maintenance is scheduled based on worst-case conditions. Sometimes it's an overkill. You shut down for maintenance where you don't need to. Think about now machine learning, analyzing the data, and you're able to predict when the machine will fail so you can schedule maintenance when it's the most convenient. So we now offer also machine learning options, accelerators, that vary depending on the cost and the performance of the processor. Now our customers also started pushing us to develop a little bit more tailored processing products for industrial. You know, Schneider was one of them. More tailored product. This product is a unique product because it's unique in its breed. Customers are asking us for an MCU, still real time, okay? Not a microprocessor, a high performance MCU running real time operating systems. They need one fast, so we gave them a fast processor. Then they needed industrial networking, especially TSN. TSN promises to replace all the fragmented legacy industrial protocols that are out there. TSN is a protocol that focuses on latency, on mission-critical communications. So we reacted, added to our industrial processors, high-speed Ethernet, TSN Max. These devices, obviously they're connected, so safeguarding the data and the device itself is paramount. So security was important. And they're also controlling motion, controlling conveyor belts. So safety. These products now have independent islands for safety and security, completely independent, to make sure we provide uncompromising performance in both security and safety. This product, clearly a product that was discussed with an ecosystem focus in mind. And because of it, this product will be at the heart of the connected factory for a long time. Machine learning. So when we talk about smart, you know, by definition, every processor is smart. But when we talk about intelligence, which is the ability to infer based on data. When it comes to that, accelerated computing is very desirable. You create this hardware accelerators that is independent, and you offload the main CPU from doing this heavy computations needed for the inference, for the decision you're about to make. The issue is that for the most part, accelerated computing is done relegated to high-end microprocessors. And that's a problem. That's an issue because it's needed everywhere, high and low. That means microcontrollers need this capability. So NXP just launched our family of products, the MCXN family of products, with an integrated NXP design neural processing unit. And obviously it's for MCUs, so it's optimized for MCU usage. It can do machine learning applications like facial recognition, voice recognition, anomaly detection. This achievement, I would say this milestone, because it's a milestone, was recognized by the Tiny ML Foundation, and they gave us the award for the best machine learning MCU this year at Embedded World. You will see a lot more of this capability in the NXP MCU families. Now, machine learning is a paradigm shift from a software development perspective. It's complex. And for the most part today, it's being taken advantage by big companies. Companies are able to invest in the tools and the resources, and that's a problem. It's a problem because many companies are being left out of a really good capability. It shouldn't be the case. The way we think about it, you should be able to download an SDK, download the applications, and use them as part of your development process. And we recognize that's not the case. We recognize that's not the case. Today, a developer will have to build the models, will have to train the models. You probably have to optimize the models to work in that target hardware. And then sometimes the models need to be, and the model parameters need to be tweaked iteratively. And it's complex. It's complex. But our goal is to bridge that complexity. Our goal is to actually eliminate that complexity. So we develop a machine learning development environment. We call it EIQ, stands for Edge Intelligence, where you can simplify the process I just talked. The developer can create the model, train the model, download models if they have them available. They have an inference engine that is optimized for NXP processors. It allows the developer also to compare algorithms, compare hardware, compare accelerators. Our goal is to bring machine learning capabilities to the masses. The EIQ and the range of products that we have in our processor family is going to accomplish just that. And I can't leave Smart Factory yet without talking about analog. Kind of remember, Dr. Ali Schneider talked about reconfigurability as a key innovation of the Smart Factory. Gotta remember, factory is full of these conveyor motors, actuators, sensors. It's all this data. This data needs to be acquired. This world is analog. So we realized that we needed the capability, a high performance capability for an analog data acquisition. A really high performance front end. So think about the factory floor. Let's say a device today is connected to a line, is reading voltage today. It's reading voltage. Make sure no spikes, looking at it. And then tomorrow, the factory floor gets reconfigured, and now it needs to be reading current or vibration. Our front end allows for that reprogrammability to follow the changes in the factory floor. Now, reprogrammability was a key innovation, but also another innovation is predictive maintenance. Our FAEs, our front ends, is able to detect the slightest anomalies. It's got a wide dynamic range. And now when you put it together with A powerful processor, you can evaluate the data, you can predict when failure will happen, and you can schedule maintenance when it's most convenient. So when you put it all together, this is our answer to solving complexity. Put it together, put our industrial processors, our PMICs, our connectivity, our security, our front end. This is our answer to complexity. This is a solution, a real solution for the smart factory. If you're an industrial, and if you're in smart factories, you need to be talking to NXP. Smart home. It's another fascinating market, and at the same time, frustrating. ABI expects there's going to be a forecast, it's going to be about 2 billion smart connected devices shipped for home by 2027. 2 billion annually. So the home is no longer a static space. It's an ecosystem that is providing more convenience, more efficiency, more pleasant living environment for the user. You know, every year devices come in smart home and they have more features, more capability, more sensors. They just a dynamic, innovative market. And despite that innovation, we still don't have a smart home. We have connected home. The user has to download 3 to 4 apps to control their devices in their home. And very likely, those devices are running different wireless protocols. The consumer deserves better. The market deserves an autonomous home. That's the use case. Not a smart home, an autonomous home. That is truly the use case. The problem we have, and we have the technology to make the autonomous home, the problem we have is they don't talk the same language. These devices don't communicate. So we need to get to a different level. We need to give our home situational awareness, so they're able to identify our intent, react, anticipate our actions. And we cannot do it unless we have the information of all the devices in our home and use that collective information to make decisions. And that cannot happen without universal language, a universal language among devices. So what's the problem? The problem is that today, companies who are targeting this market, smart home market, are focused on closed systems. Closed systems. Their vision is they can create a captive audience by a silo, walled garden approach. And I contend that that is a misguided vision. They're ignoring the power of a vibrant, open ecosystem. So what's the answer? The answer by many of the big platforms that are at the center of the home, companies like Google, Apple, Amazon, Samsung, obviously NXP is here, is Matter. Matter is a universal language, application language that works on top of existing technology like Wi-Fi, like Thread. This provides that vision of true plug and play, it becomes a reality. A consumer can go purchase a device of any brand, any OEM, as long as it has the Matter logo, bring it to their home, connect it to the Matter network, and it works. So we recognize the power, the value that could be unlocked with this universal language. So NXP started developing and joined industry leaders to develop the Matter protocol. We also started developing, from a semiconductor perspective, tons of products for the smart home. Processing, connectivity, security. We also wanted to gain additional market credibility, so we started investing in our software and development the way we enable our customers. And I understand that making IoT devices is much more than connectivity. I get that. But the reason I'm focusing on connectivity right now is because the biggest barrier and the biggest source of complexity for the smart home. The smart home is broken today because lack of a universal language. So that is the biggest barrier to get to an autonomous home. So we develop our connectivity products. Obviously, does not fit for all. It's right in for any context, and especially the case here at home. Our connectivity products are meant to match the Matter protocol, the Matter topology. So your home, your home is connected to the cloud via your router, and underneath your home, the rest of your home is connected through the Matter network. You have Matter controllers. These are devices that control any device via voice or maybe some gestures. You're able to control any device in your house. You have Matter border routers, and you have Matter devices. Some of our products are tri-radios, Bluetooth, Wi-Fi, 802.15.4, Thread, 3 radios. The products were designed for Matter. They were designed to have the best coexistence, the ability to transmit and receive in the 3 radios simultaneously, because we believe that the performance of this mesh network is key to unlock the potential of the smart home into an autonomous home. We believe the performance of this network is key to fulfill that vision of an autonomous home. Now, solving complexity for the smart home doesn't end with the tri-radios. Matter also augmented security compared to the legacy protocols. Natively, they support some state-of-the-art security provisions. They're important to mention them. One of them is a mandatory attestation of device origin. I'll explain that in a second. And the other one is the ability to provision securely a device in your home. See, our customers started asking us for help on meeting the CSA requirements for Matter, because meeting them is mandatory to get a Matter certification. So we reacted. We invested in the infrastructure, and we became a CSA product attestation authority. That means that we can generate Matter certificates, Matter device attestation certificates, which means that these certificates ensure the authenticity of the device, ensures that you are who you say you are. NXP became the only semiconductor company that is an open PAA. That means that we can deliver certificates not only for NXP products, but for everybody else. And we can do it by injecting keys at the production floor or doing it over the cloud. Customer needs no special equipment. Again, we reacted to our customers. We reacted to the ecosystem complexities, which security was one of them. And this is another reason why it shows partnering with the right companies really matters. No pun intended here, but really matters for Matter too. For those who don't know Lumi, Lumi is the largest Chinese provider for smart home equipment, and they own the Acora brand. This is an example of a great partnership. We've been partners with Lumi for 10 years. We enable them with our secure microcontrollers, wireless microcontrollers. We enable them with their products, mostly older technology, Zigbee and Thread. And then Lumi decided to expand their brand overseas. So that was a complex process, new markets, new consumer behavior, new competitors. And then they started realizing that consumer behavior was an issue, and they realized they needed to add Matter to their portfolio. And they lean on us. They lean on us to help them develop their portfolio of Matter devices. You can see the quote. It's a nice quote. It's a great partnership, and we're very proud to have them as an ecosystem partner in the smart home. So now, let's assume that from a complexity perspective in the ecosystem, you feel good. You feel good, you feel good how about you're doing in the ecosystem, you feel good about the partners that you have in your ecosystem. And then things get interesting again. You're starting to see new players. You're starting to see pressure to develop new use cases. You're starting to see pressure to interoperate with devices that you haven't seen before. And then you start realizing that different ecosystems are starting to intersect. Just at the moment that you're feeling good about it. Just now, things get interesting again. And that happens with technology. Technology tends to bridge ecosystems. Obvious example is connectivity. Users want seamless connectivity. Electrification is another example. Electrification is creating very unusual and unexpected associations between your car, your home, and infrastructure. And then you have technologies, new technologies with new use cases. They come, and their intent is to create use cases across ecosystems. They only work if they work across ecosystems. In one technology, such technology is UWB. UWB is a wireless technology used for sensing, ranging, the ability to know where an object is relative to you. And so the reason this technology is getting adopted by automotives, by phones, by IoT, is because it provides a solution to a difficult problem. Knowing where an object is relative to you with enough accuracy to make decisions. And the magic there is accuracy. There's a difference between 10 meters and 10 centimeters. There's a difference between inside the bathroom and outside the bathroom. The use cases are different. The granularity of the measurement of the distance makes the use case. Now, the first to take advantage of this performance that UWB gives you was the car, the automotive, and the phones. Phones and cars starting to deploy UWB for secure car access. But then you realize UWB gives you a lot more than that. UWB is not just to access your car and open your card. Now your car knows exactly where you are and who you are based on your phone, and is able to react to you. Is it inside the car? Is it outside the car? Is it on the left? Is it on the right? Is it on the front, on the back? The level of use case delivered by UWB, it completely augments the old car use case. In the moment that the UWB makes it in the phone, it becomes a free resource. Now you can use that free resource, connect to other devices, maybe in your home. And now all of a sudden your home has the capability to know where you are. And remember that vision that we had on the smart home as an autonomous home, as a preemptive home? Well, now you have a new toolkit. You just provided your home spatial awareness, the awareness to know where objects are relative to oneself. And now you just provided another layer to create a more rich, complex use case in your home. You know, tremendous value happens at the intersection of these ecosystems. Tremendous value. But now you need to think differently. How do you partner with ecosystem players, with ecosystem shapers? At the ecosystem, you need to now partner with companies that not only help you with one ecosystem, but they help you at the intersection of that ecosystem. One great example of that intersection of the ecosystem is Meizu. It's a great partnership with Meizu, just did. We work with them to integrate UWB in their phones. Not only work with them with the technology, but we also help them position and grab their place on this ecosystem. And this ecosystem at the intersection of auto and mobile. It's a great partnership. You can see the quote. We're very grateful of the partnership. We were learning a lot, and hopefully we provide the same value to Meizu as they provided to us. Hopefully, by now, you think of complexity in a different way. I think how to manage complexity is going to be the deciding factor between winners and losers. In my opinion, there's no doubt. So how to manage complexity, key. The thesis is you need to establish yourself as an integral part of the ecosystem. You need to partner with shapers of ecosystems, be aware of the intersection of ecosystems, and partner with companies that give you the best shot at navigating through unforeseen events. So go, become an ecosystem maker. Become a shaper of ecosystem. Become an integral part of your ecosystem. And when you're about to select your ecosystem partners, please choose wisely. Thank you.
Thank you, Rafael and NXP, for the excellent and pioneering content. And thank you all for participating at COMPUTEX NXP Keynote. Our next Acer Keynote will start at 9 o'clock tomorrow morning. We hope to see you then. Have a nice day. Thank you.